Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Welcome, everyone. It's great to have you here as we delve into the fascinating world of RAG native knowledge graphs. To start, can you provide some insights into the role of knowledge graphs in today's data landscape and how they enhance our ability to organize and retrieve information effectively?
Knowledge graphs are like a big, colorful map that helps us find our way through a vast amount of information. Imagine trying to find your favorite toy in a giant toy store filled with thousands of toys. A knowledge graph organizes all the toys based on different categories, like color, size, or type, making it easier to find exactly what you're looking for. In today's world, where data comes from many places and is often messy, knowledge graphs help us connect the dots. They organize information in a way that shows how different pieces relate to each other, much like connecting dots in a drawing to reveal a picture. This organization makes it much simpler for us to search for and retrieve information. To enhance our ability to gather the right context from this organized information, there are 3 key things to keep in mind when creating knowledge graphs. First, we need to ensure that the structure of the graph is correct and captures all the important details. Second, we must check if the information included truly represents the original data. Lastly, it's vital to understand the questions we're asking so we can extract the right information from the graph. When these aspects work well together, knowledge graphs become powerful tools for discovering and retrieving information efficiently.
That's a wonderful analogy. It really helps illustrate the utility of knowledge graphs in navigating complex data landscapes. Could you explain more about the first step? Schema validation? What are the key components involved in creating a schema that accurately captures the relevant information for a knowledge graph?
Schema validation is like building the blueprint for a new house. Just as a good blueprint outlines where each room, door, and window goes, a schema defines how information will be organized in a knowledge graph. If the blueprint is not clear or correct, the house won't turn out right, and it could even be unsafe. The key components involved in creating a schema for a knowledge graph include 1-to-1 schema descriptions. This part acts like labels on the blueprint. They help describe what each room or entity is and how it connects to other rooms. Relationships. It's important to not just name the rooms, but also explain clearly what each one is for. This prevents confusion, especially when different rooms might have similar names, but serve different purposes. EQ. Defining entities and relationships. In our house analogy, this means deciding what types of rooms we need, like bedrooms, kitchens, or bathrooms, and how they connect. In a knowledge graph, entities could be things like books, authors, or genres, and relationships describe how these entities are linked, such as written by or belongs to. 3-Y. Context injection. This is like customizing the blueprint based on the specific needs of the family living in the house. By generating a schema from questions we want to ask, we can ensure our graph captures all the relevant entities and relationships that matter for answering those questions. By taking care of these components during schema validation, we can create a knowledge graph that accurately organizes the information we want, making it easier to find and connect the pieces later on.
That's a clear and insightful explanation of schema validation. I appreciate the analogy to house construction, which makes the concept more tangible. Moving on to the second step, information completeness. How do you verify that the information in a knowledge graph is exhaustive and accurate? What methods or techniques are commonly employed to identify missing entities or errors in entity resolution?
Verifying that the information in a knowledge graph is complete and accurate is like checking a grocery list before leaving the store. You want to ensure you have everything you need and that there are no duplicates or missing items. To check for completeness and accuracy in a knowledge graph, there are several methods and techniques commonly used. 1. Zooming in and out of the graph. This allows users to look closely at specific areas of the graph to see if any important information is missing. just like scanning your grocery list. You can quickly identify if any key items or entities are absent or if relationships are not clearly defined. They're into entity extraction and resolution. Sometimes, the process of identifying and categorizing different items can fail. For example, if two names refer to the same person but are spelled differently, that would be an issue of entity resolution. By using algorithms that can identify these connections, you can ensure that all entities are correctly represented without duplicates. 3. Testing with specific queries. By asking the system specific questions based on the entities and relationships you expect to find, you can evaluate whether the graph is missing information or if the queries themselves are flawed. This process is like double-checking your grocery list to see if you wrote down the correct items. Utilizing tools for pattern recognition. Automated tools can help identify common patterns or relationships that are likely needed, but may not have been included in the graph. This is akin to having a friend remind you of items you might have forgotten while shopping. By employing these techniques, you can systematically identify any gaps or errors in the knowledge graph, ensuring that it accurately reflects the necessary information and relationships.
Thank you for joining us today. Let's recap the key takeaways. Knowledge graphs connect information like maps, improving data retrieval. Schema validation ensures a well-structured graph by defining entities, relationships, and schema descriptions. Now, information completeness checks accuracy using techniques like zooming in out of the graph, entity extraction and resolution, query testing, and pattern recognition. Context injection tailors the graph to specific queries. By applying these principles, we can create effective knowledge graphs that empower efficient data retrieval and analysis. Thank you again for your attention.